Okay, for the lab, we determined the total time the ball was in the air and how far it flew horizontally, sometimes referred to as range. This is the givens in our lab. We want to know what velocity the ball left our hand and at what angle it left our hand. So a little sketch would look something like this. Now, one of the assumptions we're making is that it left our hand at ground level, so there's a little bit of error there we'll have to deal with. There's our range, the distance the ball flew. There's our angle theta. And we also know, and this is a known, and we also know T total. Okay? So when we think about this initial velocity, it is made up of a horizontal component and a vertical component. If we can figure out the vertical component and the horizontal component of the velocity, then we can use Pythagorean theorem and figure out the velocity it left our hand. We can use a little bit of trig and figure out that angle. Okay? So the v sub x, as I've already mentioned, is horizontal and constant. And that's a big thing in all these projectile problems, all of these 2D motion problems. We are going to assume no air resistance. We are going to assume that whatever horizontal velocity we start with carries throughout the whole problem. And v sub y is vertical and changes with gravity. Okay? So let's tackle the horizontal case first, because the fact that it's constant is going to help us out quite a bit. And the equation for the horizontal component of velocity is simply going to be the distance it covers in the time it covers it. Our basic equation for average velocity. And the distance it covers is 33.528 meters in 3.62 seconds. Remember, the lab we have measured in feet. You're going to have to use the conversion we talked about to convert that to meters. Okay? So now I have, when I do that math, did anybody do that? 9.262. 9.262 meters per second is my horizontal velocity. And let's take this to 3 decimal places. I'm done with that piece of the problem because it's constant. All right? So now let's talk about the vertical component of velocity. What we have to remember there is that T total equals T, what I refer to as T peak, the time to the peak, times 2. Because again, we're assuming perfect parabolic flight. So that means the peak is halfway through the total flight. So in this example, my T to the peak is going to equal T total divided by 2, or 3.62 seconds divided by 2, or 1.81 seconds to peak. Now, if it takes 1.81 seconds to get to the peak, and we got to go back to our free fall problems, that would mean that if I throw up a ball, if I throw a ball up, that still doesn't sound any better, and it leaves my hand at 9.8 meters per second, how long will it take to get to the peak? 1 second. All right, so we need one of our kinematic equations to help us figure that out. Nobody's probably got those handy, do they? Okay, so we know time, right? We want to know our initial velocity. That's not going to help us. That's distance. We know time. We know time. We want to know this velocity. How about this one? We know time, we know acceleration, we know our final velocity. Is that going to work for us? Yeah, that's our equation, right? So, V sub f equals V naught plus AT. V sub f is 0. V naught is what we're looking for. A is negative 9.8 meters per second squared. And T we just figured out to be what? 1.81 seconds. With me so far? So if I plug these things in, I get 0 equals V naught plus negative 9.81 times 1.81. So negative, that's going to be positive now, 9.81 times 1.81 equals V naught. And on my calculator, what does that work out to be? 9.8 times 1.81. V naught equals 17.738 meters per second. With me so far? Now let's go back to that little triangle that we had. Now, V naught, and this is where the notation gets confusing. This is V naught in what direction? The vertical, the y direction. Very good. So we probably ought to call it, for just to keep it straight, V naught y. So in our triangle then, back to the first page, oops, pressing too hard there, we just figured out that this was 17.738. The horizontal was what? 9.262. Can you use your trig skills to figure out V naught and the angle? Sure. Let's do the angle first. Theta is going to be the inverse tangent of 17.738 over 9.262. Making sure I'm in degree mode, I am. Inverse tangent of 17.738 divided by 9.262. Theta equals 62.428 degrees. Now, if you remember how I threw it, I know your eyes were trained on me as I threw the ball. Do you recall that I tried to throw it more up in the air than most people? So it makes sense that that's 60-degree angle roughly. Okay? V naught is going to equal the square root of 17.738 squared plus 9.262 squared. On the fancy calculator, 17.738 squared plus 9.262 squared. Almost exactly 20 meters per second. And that is a description on how the calculation is going to go for your lab.